So I'm Alex Miller, and I've been working with Clojure for about 7 years and working on Clojure for about 4 years at Cognitect. And I work on the core team and help develop new features and things like that. This is actually the first time I've done a technical talk at a Clojure conference, because usually I'm emceeing them. So you get the first one. So this talk is called Dependency Heaven, which maybe is not a place that we will actually reach. That may be an unattainable goal, but it's really in opposition to Dependency Hell. This was really just a fun opportunity to make the slide, which is something that a lot of developers describe as sort of the nuts and bolts of their daily existence of managing dependencies on their project and using dependencies and things like that. And this is something that we've actually been working on the core team, some different things for off and on for probably 8 months or more seriously for the last month or two, really because it is in the line of trying to get Clojure 1.9 out the door. And I'll get to why that is here in a little bit. But what are the problems? There are actually several clusters of problems related to dependency management. And I've sort of bucketed these into version resolution, our artifact focus, and getting started. So this is a one-slide summary of Rich's speculation keynote from the Conj last year. It is well worth your time to go watch the hour-plus talk version of Rich talking about these subjects, much better than I will be able to. But this is an important sort of background, so I wanted to at least talk about a few different things. One of the key things in his talk is really about this notion of change, which is a word that we throw around a lot in software, and he wanted to make a distinguish between two different kinds of change, growth and breakage, where growth is really accretion, which is adding new things that you can use, relaxation, which is where you either require less from people that call you or provide more to people that call you. Those are ways that don't break existing code. Or fixation, just actually fixing the implementation of something without changing its interface or things like that. And then breakage is something that people also call change, and that's when you require more from your consumers. Either they're calling new APIs or you require them to call new APIs, or you require them to pass you more stuff, or you provide less on the return. Those are all kinds of changes that basically break an existing consumer's use of your code. And the key insight here is that if software only uses growth, only uses those techniques, it's always okay to use a newer version. There's never any problem with sort of hitting a breaking version because your software does not break. And this is something we strive for in the Clojure API, which is one of the reasons that it has a lot of stability. For a long time, that's been sort of implicit. This is sort of making that more explicit, and something that we want to be more serious about and would like other people to be more serious about too, because breaking software sucks, and so we should just stop doing that. One way to avoid breakage is by making new names. And so we should not be afraid to make a new name that for an existing function, give it some new name and leave the old one there. Existing consumers continue to use it. New consumers can use the new one. If you need to remove a function or significantly modify things, put it in a new namespace. That's fine. So there's ways to do this at the sort of collection level as well. And one tool that we have in 1.9 now is specs. And specs allow us to make commitments about our code. And specs are really about what you can do, not about what you can't do. And some of the things that you can't do in spec are specifically designed around avoiding prohibiting things. Prohibiting is a thing that turns growth into breakage. So if you suddenly need to require a new attribute, or need to allow a new attribute, and before we had a spec that said you were not allowed to have that attribute, then you've turned growth into breakage. And so we don't want to do that. That's the wrong direction. And then Rich also talked at length about semantic versioning and how semantic versioning basically has these 3 levels of major, minor, and patch changes. And change at the patch level is just fixing. It's really fixation. Change at the minor level is really accretion or relaxation. And change at the major level is breakage. And so Rich's point there is that semantic version itself is broken and that it allows breakage. And you don't have to break things. You can just add instead. Dependencies. So this is moving into the second part around artifact focus. Artifacts, right now, we declare our dependencies at the artifact level. We declare that we depend on core async or Clojure or whatever. And those artifacts are stored in Maven repos. So there are some good things about this. The Maven repo is an immutable append-only distributed store. All that is awesome. That's the same things we like about persistent data structures, about Git, about Datomic. All of those things have the same property of being immutable append-only stores. So like last year when Clojure had some downtime, it is conceptually, architecturally easy to add a mirror for that stuff because it's just caching. You're taking this stuff and I'm going to cache it somewhere else and I can go choose what I do with those caches. Caching is a really easy thing conceptually compared to building a distributed system that has to deal with updates and deletes, things like that. The Maven repo system also gives us access to the vast Java ecosystem of libraries that already exist. And so that's goodness. We don't want to get rid of those things. The bad things. Clojure doesn't actually care about artifacts. Clojure doesn't, when you start the JVM, you don't give it, you don't talk about artifacts, you're building a class path. Clojure doesn't actually require stuff to be built at all. You just need Clojure files that are on the class path somewhere. And so we have sort of added this constraint around how we use Clojure code that is artificial. And it has the downside, it has the upside of allowing us to play in the Maven ecosystem and do those kind of things, but it has the downside of disallowing certain things that the JVM allows and the Clojure supports that would be useful. So we've also sort of entangled this problem of dependency management, how we say which code we need to use, and artifact production, our build systems, our build tools, and things like that. Those two things are entwined in something like Linigan or Boot or Maven, all those kinds of things. There are lots of cases where we run into this restriction. I don't know how many people have needed a database driver that was not in a public Maven repo. That's a common thing. So that's an example of, I might have a jar file, I want to use it on my class path, but I can't get it out of a repo. And in that case, you have to do all sorts of crazy workarounds to make that work, and that's dumb. Or you might run into the case where you have your project split into multiple code bases, right? You have multiple, your application is split into multiple projects. And in that case, you have to do this cross-project dev, and you use checkouts or something like that to deal with that. But that's silly that we have to do that. There's no reason that we can't start a REPL and include all of these different source files that are all over the place and work with them directly. The JVM does that. Clojure does that. Our artifact focus has prevented us from doing that. And then the other thing is that the source of truth for most of us now is files in Git on GitHub. And we can't just use those things directly right now. But it would be useful to do so. And so I think that's something that also, like there are Clojure files in GitHub that we could get to. And we don't really care about the fact that they get packaged into artifacts. They might be useful without that. And the ugly part of it is that our dependency declarations are lies. They're actually not even true. What we say when we specify a library is we are requesting this version of a library. But when we go actually build a class path or we build an Uberjar or whatever, you're actually running a Maven algorithm that's going to expand the full tree, and it might find multiple versions of a library, and it's going to pick a version for you based on a bunch of constraints and rules, some of which are based on semantic versioning, which has these issues that we've talked about. So it's very possible and actually likely for you to end up with a set of versioned artifacts on your class path that are a set of versions that you never specified and that you've never tested with. That's actually a pretty easy thing to happen. And so that's pretty ugly. We would really like things that we do right now with things like dependency management in Maven or now in Linigan that was added within the last year or so, is really the ability to specify an external source of truth for dependency versions. We should be able to do that. That's just a thing that's useful, and there's lots of cases for that. So moving on to the third set of problems, the getting started experience. For a long time, you've been able to just download the Clojure jar and run Clojure main directly out of the Clojure jar, and that was maybe not the friendliest thing that you could do, but it was at least relatively easy to do. As of Clojure 1.9, Clojure itself has multiple artifacts now. Clojure depends on spec. It also depends on the Clojure core specs library. So there's actually at least 3 jars that you need in your Classpath to start Clojure. So a new user is immediately confronted with this problem. It is no longer, we've sort of moved past the point where that was possibly tolerable. This seems like something that we had to have a better solution for in 1.9. And that's how this has sort of gotten into the top of my queue, basically. Because my primary goal right now as a top-line goal is getting 1.9 out the door. And this is in the way of that. So that's the reason I've been working on it lately. So what are we going to do about it? So we've been working on a new contrib library, tools.deps, .alpha initially. I expect that initially that's going to be, or relatively soon that will move out of alpha and it'll move into a more stable release. I'm not sure if that will happen before 1.9 or after 1.9. It's really not particularly important for most of the other stuff. A Clojure installer that can provide a way to get the latest version of Clojure and tools.deps onto your system. The Clojure installer does not assume Clojure, so it's not written in Clojure, it's written in Java. We do make that assumption that you're going to get Java on your machine somehow beforehand. And then system-specific installer packages for brew or apt-get or chocolatey or whatever is the right thing for your system. So these are the things that I've been working on, and a substantial portion of this is now exists and works and will be released soon, whenever I have time to do all that. So tools deps alpha. The high-level constraints here are the sort of ground truth of what we have to deal with is that when we start the JVM, it takes a class path. And so we have to be able to build a class path. We have to be able to do transitive dependency traversal. That's just a fact of life. Dependencies depend on other things. We have to be able to download artifacts from Maven repos. So those are all things that we know we're going to have to do. Sort of the high-level process that we've settled on after a lot of discussion is really starting from an initial set of dependencies, applying this operation called resolve deps that can expand the transitive dependencies, resolve version differences, fail on version conflicts if you find those, and download those artifacts to your actual system. And the result of that is going to be a thing called a library map, which I'm going to talk more about. There's also some extra use cases there on the bottom. I will also talk about those more. And then a second operation, make Classpath, that really takes a library map and then produces the actual class map out of that, which is the simpler of the two operations. So what are the steps in resolving deps? We have to start with the initial deps, expand the transitive dependency graph, resolve these version differences, and return this library map. 3 extra use cases that we've drilled into. We looked at a lot of ways that people use like Lanigan profiles and different features out there in the wild today. And these are the 3 use cases we focused on. The need to add extra dependencies when we're creating a class path. And that's common when you're doing sort of development time, or you're at development time, and you're trying to add some extra testing libraries. You might want to add criterion to do benchmarking or whatever, something like that. So it's not part of our core dependency set. It's not what you need to use the software, but it's an extra library that I want to use right now for whatever purpose. We have the problem of overriding dependencies. So say I know that I'm going to have this dependency show up somewhere in the expanded dependency graph, and I'm going to tell you that I'm going to use exactly this version of it. And I don't care what version comes out of all that stuff. I'm going to override to just this one. And then default dependencies. In the case where you have a dependency that shows up in the dependency graph and it doesn't have a version or it doesn't have a version specified, then use this version. I'll tell you what version to use by default. And then I think a 4th case maybe that needs a little bit more thought is exclusions. And so that's, Rich and I have not had a chance to talk about that in depth, so I will table that one. So the output of all this is a library map. The library map has as a key the library, the user's intent to use Composure. As the value, it has a coordinate, which is both a version and some particular implementation to use, and an actual path on disk of where I can go find it. And so it's implicit in this thing that part of doing resolve deps is that it's actually got to download a jar or make a path available somewhere on disk. Did I skip anything? And then so making a class path, our goal here is to generate a class path, which is just a path separated string. What is the class path? Class path is an ordered list of class path roots. Those roots can be jar files, they can be directories. There's also some special syntax to include like a glob of jars, but really the key thing is it's either a jar file or a directory. What are its characteristics? And this is something we went and looked at. And one of the things that you will notice immediately when you look at it is that Classpath has an order. It's a sequence of things. And that order is important because that's the order that the JVM will look in those different roots for things. So the question is that order actually important though? Is it actually relevant for the class path? The only case so if all of your classes exist only in one of your roots, then it's not relevant. The JVM will find it across one of those roots, and it really doesn't matter. The cases where it is relevant is when it's in more than one of those class path roots. I'll contend that most times this happens, it's actually a bug. I don't know how many people have debugged something where you had the same class in multiple jar files. That's awful, right? It's really hard to figure out. And most commonly happens when you like accidentally AOT compile downstream dependency classes into your jar file or something like that. So I'm going to contend that's a bug, and we should not do that. And if it does happen, it's a problem, not an intended use case. The other case that you do see fairly frequently is including another class file into your class path in a different root, specifically for the purpose of overriding the one that is already there. And so that one's kind of interesting, is like I have this class path, I'm getting this class file from somewhere, but I actually want to use a different version of that for, I'm going to override it with a specific version. So our contention is that that's really that's really a good use case, and we should be sure to support that. But the way that people do that with prepending is really more of a hack than doing what they want to do, which is to say, I want to go to this particular thing in the class path and replace it. And so we should support replacement, that's fine, but we don't really have any goal or interest in supporting prepending for the purposes of overriding. And so if you get rid of that, and if you say, then we can say basically that order is not that important. And so we're going to give up on trying to maintain the ordering in a class path, and instead try to provide other operations that give us that same functionality. So we have, so around tools deps, we have a script. The script is called CLJ. The real point of CLJ is effectively to run Clojure.main. And you run Clojure.main by running Java. So Java has some JVM args. We need to have a class path, and so that's where we will do more work. We're going to invoke Clojure.main and then take args for Clojure.main. Clojure.main can be used to run a REPL. That's the default with no arguments. It can be used to run a Clojure expression and just give you the result back. And it can also be used to run the -main function in any namespace. So you can use it as a general runner as well. And it could be used to run tests even that way with a little bit of additional glue code. So that's all useful. The main question here is how do we construct the class path? And the first thing we need is some way to remember which dependencies we care about in the current context, the current directory. And we're doing that by storing that in a file called deps.eden, which is obviously an Eden file. And it has a number of different keys in this map. The deps key is the main one, and that will store a mapping from the library to a coordinate. You'll notice that that this is slightly different than the syntax in Leiningen or boot or other places. And there's a reason for that. We're trying to add some additional context here about where this particular library is coming from. And right now it's coming, everything's going to be coming from Maven, but we're sort of expanding the ability to sort of build pluggable systems that pull artifacts or directories even from other locations. And so imagine there's other kinds of types there as well, like files and maybe GitHub, things like that. Deps.eden can also include aliases to cover any combination of these different use cases that I talked about, override deps, extra deps, things like that. Looks like I've got a typo in there on extra, but so here I've created a couple different aliases, one called bench that includes criterium. I also included one for 1.9. You'll see a lot of times in Leiningen profiles, people will have profiles for a bunch of different Clojure versions to do matrix testing type stuff. And that's something that's easy to do here as well. It could be done even at a sort of user-wide level rather than at a project level. I mentioned coordinates a little bit. The library version coordinates contain this type indicator. I've already mentioned most of this stuff. It's that type flag ends up flowing down through some multi-methods to an extensible system. So this Clojure script also takes some extra arguments that allow you to activate aliases that are used to build the class path. And so this -r will give you some additional resolve arg aliases that can pull in additional functionality. And then you can use multiple of these as well. So a command line like this will actually pull in both the benchmarking alias, which included criterium as an extra dependency, and 1.9 as a way to override my Clojure dependency and use a specific version of Clojure. And I think that these things can be sort of mixed and matched and combined to cover a wide variety of use cases. Most of the things that I'm aware of out there. You can also specify these sort of last-minute class path overrides, the overrides that you get in making the class path to say, I want to specify a hard-coded directory location or jar file to use instead of whatever you found during the transitive dependency walk. You can either use -c to pass an alias that maps to something that's in the deps.eden file, or you can use -p to build an explicit map actually on the command line directly. And so you can sort of swap something in if you need to debug with a specific version or something like that. Another benefit we get here is that one reason we built all this stuff into aliases is to have names for single or combination of these things that activate the building of different class paths. And so both the intermediate libs map and the final class path are cached in the local directory in a dot directory. If the class path, given the set of flags you specified, exists and it's newer than deps.eden, so nobody's changed what those things mean, then that cache CP file can be used instead, and you can avoid invoking another JVM with tools deps to build the class path. You already have the class path. It's sitting in a file. It's just a string in a file, and you can just spit it directly into the class path, into the command line that's going to start Java. What CLJ does not do is AOT compile things. It doesn't package things into jars. It doesn't deploy things to Clojars. It doesn't do any of those things. And that's pretty intentional, is that we want to disentangle these sort of build and artifact deployment kinds of use cases from the actual dependency management use case. So the initial audience here is really focused on new users that are just getting started, or any existing Clojure user who wants to do sort of more ad hoc REPL-based development, things like that. It will work really well for that. I think there are vast opportunities to integrate these things with Leiningen, boot, whatever, in a couple different directions, either coming from those tools or going to those tools, and all those things are just a little bit of glue code, I think, to do those migrations. And I think it will require a little bit more work to figure out what the best way is to do those kinds of things and where they make sense. We also need some way to get all of this stuff onto the actual system. And so we have a new Clojure installer, and this is a Java app that basically uses Maven Resolver, which is the thing that used to be Ether. That stuff has been pulled out of Eclipse and moved into an Apache project and is now called Maven Resolver. But that's basically using the standard Maven APIs to find the newest stable version of Clojure and tools deps alpha. And so it's going to go out there and say, I'm going to find Clojure 1.8. I'm going to use tools deps 0.0.3 or whatever version that is. And it's then going to record that into a system level, really user level, deps.eden file. So you can remember that. And that'll actually be used by the CLJ thing as well. So if you try to run the CLJ script and you don't have a local deps.eden file, it'll use the sort of user-wide deps.eden file. So you can just start a Clojure REPL anywhere by just doing CLJ. It also writes the class path for tools deps, for using tools deps itself. So inside that CLJ script, if we determine that we need to build a class path, you have to then invoke tools deps, which means you need to run a JVM, which means you need a class path, and you need this class path. And so that's a bit of work to do that. But that's a one-time thing to do that. And then after that point, you basically have tools deps on your system. You actually have enough functionality at that point to effectively do that work again anytime you need to. So this is sort of a bootstrapping operation. I've written a brew formula for OS 10. I'm on OS 10, so that's what I care about most immediately and what I can easily test. And so that's where I've started. Obviously, there's a lot of other things as well, and I would welcome help in making those things, and would love to start making Clojure packages that on a regular basis. It's not a thing that we don't actually need to update this every time that you run Clojure, because the installer has the ability to find the newest stable version of Clojure. When 1.9 is released, the existing brew formula would actually find the newest version of 1.9 and use it when you ran it. So the only time you really need to install a new version of the installer is when the installer itself changes, which is, it's basically like 50 lines of Java code or whatever. So hopefully that would, well, the other thing it installs are the scripts, so the CLJ script itself. And so that would be the other kind of a change that would require updates. But I envision that this is the sort of thing that after the initial period of development could probably go lengthy periods of time without being modified at all across multiple Clojure releases. That is at least the goal. So there is more work to do on the different provider types. I've done some tinkering. We've started to do some serious work around sort of using local directories and depending on local directories that have their own deps.eden file and allowing that stuff to all work outside of any artifacts. And that's sort of in work. And then we've done some talking about utilizing Git and GitHub and things like that. Haven't actually done any work on that yet. It is an open protocol, so it is possible to add other things as well. If people have ideas, I would love to hear those. There are a few different niceties on the command line that I would like to have that I have not added yet. Some more assistance around the format of the deps.eden file and ways to dump the class path out of the cache and things like that. More installers I already mentioned, and integration with build tools I've already mentioned. So those are all things for the future. And I think that's it. That's all I have. And these things don't exist yet, but they will as soon as I get a chance to make them. And I think I have another 10 minutes, so I'm happy to take questions. But I'm not going to run up the mic with you because I can only do so much.